All right, 29. So a skier is lifted to the top of a 103 meter tall mountain. How much work is done by the lift? So when you're looking at this problem, you know it's a work problem. And there's two equations for work. Work equals force times distance, and then the work equals the change in energy. And remember, the way we've written the change in energy is kinetic final plus potential final minus kinetic initial plus potential initial. Okay. So either of those equations will work. You have to decide which one makes the most sense to you. So I'll show you both of them because you're going to end up with the same answer. And it just depends on which one you find to be easier. Okay, so let's start the way I would start. The way I would start is W equals FD. Because that's kind of what it's talking about. It's work being done to move a distance. In this case, it's work being done to lift a skier up a mountain. Okay? So let's color code these a little bit. Okay, so work equals force times the distance. Now the distance, I know it's 103. God bless you. So work is force times distance. So I know what the distance is. The problem is it doesn't tell me what the force is. But I can figure out what the force is because the force is equal to what you have to do work against. So what am I doing work against? Gravity. I'm doing work against gravity. So the equation I need to use for force is mg. And that's on your equation sheet, so you don't have to memorize that. Okay. So mass is what, 78 times g, which is 9.8. So you just multiply all that stuff together. So 78 times 9.8 times 103. And you get 78733.2. Huh? Yeah. So that would be how I would do the work. But that's not the only way you can do the work, because some of you may find it easier to say work is equal to change in energy. And that will absolutely work too. So you're asking yourself, what kind of energy is changing? Well, it's not talking about anything with motion, right? It's not talking about the motion of the skier. The skier's not moving. The skier's not stopping. The skier, they're just moving the skier. So the kinetic energies are both going to be zero. Okay? So you don't have to worry about a kinetic final. You don't have to worry about kinetic initial. So all you have to worry about is potential final and potential initial. So work is equal to potential final minus potential initial. Well, where does a skier start? Skier starts on the ground. Well, we've usually been calling the ground zero, so that means you don't have to worry about the potential energy initial either. So all you have to worry about is potential energy final, which is mgh. M is 78, g is 9.8, h is 103. You end up with, shocker, 78,733.2. Okay? So that's what you end up with. So you can do it either way. You can do work is force times distance. You can do work equals change in energy. It just depends on what makes the most sense to you. I think of it as force times distance, but a lot of people think of it in terms of energy change. Either one's fine, doesn't matter. Okay?